All right, this is a solutions video for practice FRQ Unit 8, Scientific Measurement and Calculations. Working with the first problem. This is addition and subtraction. On addition and subtraction, remember, we line up that decimal. So as we add up these numbers, there we go. But that's not the correct number of sig figs. For the correct number of sig figs for adding and subtracting, remember, we go to the least precise or a visual way to do it. You drop the line after the one that finishes first. Right? So now all of these are sig figs on the left-hand side of that line. But don't forget that sometimes you have to round up. Okay. For multiplication, this is where you're just going to put it into your calculator. 8.7456 divided by 0.12345400 equals 161,955.5556. This number has 5 sig figs. This number has 4 sig figs. Those zeros count. So my final answer is going to have 1, 2, 3, 4 sig figs. Okay. But here, don't forget to round up. So now we're going to have 162,000. Right? And we're going to move over the decimal point over 1, 2, 3, 4, 5 times. So that's going to be 1.620. I want 4 sig figs times 10 to the 5th power. Next question. Again, for addition and subtraction, we line up the decimal. So that's 540,000. And even though there's not a decimal there, we assume it's going to be there. We line it up with the 846.51. When we subtract, again, don't forget to carry the zeros. Again, or you just use your calculator. So that's 540,000 minus 846.51 gives us 539,153.49. As before with the other addition problem, what we're going to do is we're going to drop that line after the least number of sig figs. This one goes all the way to the hundredths place. This only goes to the 10,000ths place. So we drop the line right there. These are the only sig figs. Don't forget to fill in, round up, and then fill in the placeholders. We're going to move the decimal here. So that's 1, 2, 3, 4, 5. That's 5.4 times 10 to the 5th power. Next one, we're going to just use our calculator. That's 9.56748 times 47.84, and we get a raw answer of 457.7071907. That's the number I get out of the calculator. But remember, we got to watch out for sig figs. Here we're going to count 1, 2, 3, 4, 5, 6, 7 sig figs. Here we have 1, 2, 3, 4 sig figs. So my answer is only going to have 4. We go with the lower number. We don't have to round that up. So we can stay with 457.7 because it's between 1 and 1,000. That's an acceptable answer. Or put in scientific notation, 4.577 times 10 to the, move the decimal point over, 1, 2. Either answer is acceptable. Next. For each of these, we're going to round to the defined number of sig figs. Right. So here we have the first sig fig is a 3, and they're asking for 2 sig figs, so we're going to go 2. But this is a 5, so we're going to round up. So that would be 0.00035. All right. Now we got to put it in scientific notation. So remember, we add a digit, a decimal, and all other sig figs times a magnitude of how many times did we move the decimal. We start here, we're going to move here. 1, 2, 3, and 4. -4 because it went smaller. Here, we're going to round to 4 sig figs. Here we have 1, 2, 3, 4. I don't have to round up. And that's already in scientific notation. So it's 1.033 times 10 to the 4th. Here we're going to round to 5 sig figs. That's 1, 2, 3, 4, 5. Hey, the next number is a 5, so we're going to round up. So that would be 17.992. But then we got to put it in scientific notation. We're going to put the first digit or sig fig and then a decimal and all other sig figs. Then we're going to multiply by how many times we move the decimal. So if I moved it 1 time, and this is a bigger number, it's 10 to the 1st. Next one, ask for 3 sig figs. So we can go 1, 2, and 3. We have to round up, so that's going to be, it's already in scientific notation, so it's going to be 3.37, because again, we got to round up, times 10 to the -5. Now, for the next problem, we are going to convert 15.8 decicandelas to candelas. All right, so we're starting out with 15.8 decicandelas, and in the end, we want to get to candelas. Well, we got to convert the deci into regular candelas. We're going to put decicandelas on the bottom, right, so they can cancel. Regular candelas on top, because that's what we're looking for. I'm going to put a 1 in front of the prefix, and deci is a small number, so it's going to be to the -1. Decicandelas will cancel. Candelas are left over. So I can write this as 15.8 times 10 to the -1. That is not in scientific notation, right? Remember, it has to be a digit, a decimal, and then all other sig figs. So I'm going to move over the decimal point 1 time. And since I increased the exponent, since it's going to be a bigger number, increase it. I'm going to increase it by 1. That's actually 10 to the 0. Oops, candelas. Don't forget the units. Next one. Let me center this up. We're given, we're here to find the mass, right? And then the only mass that we have is grams, so we're going to say we're looking for grams, right? They gave us the volume, and they gave us the density, right? So since the density has grams in it, that's 5.3114 grams over centimeters cubed. I'm going to put a 1 as a placeholder. I don't want to mess with the grams because that's what I'm looking for. But I do have to get rid of centimeters cubed. So we have centimeters cubed right there. That's 71 centimeters cubed. Put a 1 on the bottom as a placeholder. Get my calculator. 5.3114 times 71. Right. That gives me an answer of 377.09094. Obviously, I can't use all those numbers, so I got to count the number of sig figs. Here I have 1, 2, 3, 4, 5 sig figs. Here I have 1, 2 sig figs, so that means my answer is only going to have 2. That's 380, or to put it in scientific notation, 380, no decimal point, because again, we only have 2 sig figs. That can be an answer, or to be better, I would put it in scientific notation of 3.8 times 10 to the, I moved the decimal point over 1, 2 times grams. All right, let's move on to the next problem. All right, looking for density. What is the density? And they ask us in grams per centimeters cubed, right? But the problem is our weights are in pounds and in inches. All right, so here's the deal. Pounds is a mass, just like grams is a mass. And we're going to start out with the mass of 0.652 pounds, and put over 1 as a placeholder. All right. And then it says it has 8 inches on each side. All right, so that means it's going to be 1 over 8.00 inches times 1 over 8.00 inches over 1 over 8.00 inches. Now, for 1 kilogram, you have a conversion factor in your charts on page 3 of 2.20 pounds per kilogram. At this point, your pounds cancel. You got kilograms, but again, we need grams. So let's convert that kilograms into grams. For every 1 kilogram, it is 10 to the 3rd grams. Kilograms cancel. And then we have these inches that we got to get rid of. The grams are good, because that's what we're looking for. And then so we're going to convert each of these inches into centimeters. Now we can't do it one time, we got to do it 3 times. So for every 1 inch, it's 2.54 centimeters. I'm running out of space, but hopefully you can bear with me. 1 inch for every 2.54 centimeters. And for every 1 inch, yeah, this got messy, 2.54 centimeters. 1 inch. Now, what that does is, for every inch, there's 1 on top, 1 on the bottom. For every inch, 1 on top, 1 on the bottom. Every inch, 1 on top, 1 on the bottom. And now we got centimeters times centimeters times centimeters, which equals centimeters squared, cubed. All right. So here we go. Put this all in the calculator. This is going to be 0.652 divided by 8.00, because it's on the bottom. This next one is also on the bottom, so we put divided by 8.00. This is on the bottom, divided by 8.00. This is on the bottom, divided by 2.20. This is on top, times second EE to the third power. This is on the bottom, divided by 2.54. This is on the bottom, divided by 2.54. And again, if it's on the bottom, you push divided before it. And then I get an answer of, hang on. Zero point 0.03532263, but of course we're not going to go with all that. We're going to go with the number of sig figs. Here we have 3 sig figs. Here we have 3, 3, 3, 3. Infinite number of sig figs there, 3, 3, and 3. So our final answer is going to have 1, 2, 3 sig figs. That's going to be 0.0353, or we're going to convert that into scientific notation, 3.53 times 10. It's a small number, 1, 2, -2 grams over centimeters cubed. In our next problem, we're given the density, right? They're asking for volume. Now, they don't ask what units, but you have centimeters cubed. Oh, they ask for centimeters cubed, and they give you a mass, right? So in the end, you're looking for centimeters cubed. The problem is there is no centimeters cubed out here. There is a milliliters that we can convert into centimeters cubed. Now, here's the thing. This is a volume and this is a volume. But this is a 4.550 grams per milliliter. The volume's on the bottom. So that means we have to do the inverse of it. So we're going to put the 4.550 grams on the bottom, and we're going to put the volume on top because that's what we're looking for, volume. I'm going to put a 1 there as a placeholder. Now, there is a relationship between centimeters cubed and milliliters that you should know. 1 milliliter is equivalent to 1 centimeters cubed. Milliliters cancels. We got centimeters cubed. Great. We're looking for that. Don't change the centimeters cubed. We got grams though. We got to get rid of grams. Luckily, we have the 1.24068 grams up on top. Put a 1 on the bottom as a placeholder. Grams get canceled out. So now we have 1 divided by 4.550 times 1.24068. That gives us an answer of 0.27267,923. We have to now look at number of sig figs. Here, there are 4 sig figs. This is a definition, so it's exact. So it has infinite number of sig figs. And here we have 1, 2, 3, 4, 5, 6 sig figs. So that means our answer should have 4 sig figs. That's 1, 2, 3, and 4. Next number is a 7, so we got to round that up. So the answer is going to be 0.2727 centimeters cubed, or put it in scientific notation, it's going to be 2.727 times 10 to the, I moved the decimal point over 1 time, and it's a small number, -1 centimeters cubed. Our next problem. Speed limit in school is 25 miles per hour. So we have one number there. We want to change it to meters per second. So to put it in meters per second, that means we got to change our 25 miles per 1 hour. All right. So let's convert the miles. In your reference page, it says that 1 mile is the equivalent of 1.61 kilometers. Okay, we got the miles canceled out, but we got kilometers. Again, we're looking for meters. So let's convert that kilometer. We're going to write down the kilometer on the bottom so it cancels out. Compare it to meters. We put a 1 in front of the kilometers. And kilometer is 10 to the third meters. Kilometers cancel out. We got meters left over. Great, that's what we're looking for. Don't mess with it any further. Next, we have hours. You know that 1 hour is exactly 60 minutes. That's important because it pertains to the number of sig figs. Hours cancel out. Again, as long as one's on top, one's on the bottom, they cancel out. Now we have 1 minute equivalent to 60 seconds. The minutes cancel out because one's on top, one's on the bottom. I got seconds left over. So it's calculator time, where we have 25 times 1.61 times second EE3 divided by 60 divided by 60. Okay. And that gives us a raw answer of 11.1805556. All right. So now we got to look at sig figs. 2 sig figs here. Because it's from the imperial system to a metric system, it has 3 sig figs. This is a conversion factor within the same system, the metric system. So it has infinite number of sig figs. 1 hour is exactly 60 minutes. That's a definition. This is also a definition. So we're limited to 2 sig figs. That's your 2 sig figs right there. So you can just say 11, don't forget the units, meters per second. And the last one. We're going to start out with this measurement of how much the gas is in Japan in yens per liter. All right. And we want to know how many dollars it is per gallon. All right. So we want dollars per gallon. We're going to start out with 175.00 yen per 1 liter. In your book, you can see that there is 3.78 liters. We put liters on top so the liters can cancel. And then we got gallons on the bottom. Here, liters are going to cancel out. We got gallons left over. We have yen that we want to change into dollar. Luckily, we have a conversion factor of $1. $1 is equivalent to 145.755 yen. The yen cancels out. We have dollars left over. Great. We got dollars and gallons, dollars and gallons. That's exactly what we're looking for. Get your calculator. 175.00 times 3.78 divided by 145.755 gives us a raw answer of 4.538 4, 3, 7, 7, 8, 9. All right, let's look at sig figs. Here, there's 1, 2, 3, and these zeros count, 5 sig figs. Here we have 3 sig figs. Here we have 1, 2, 3, 4, 5, 6 sig figs. So our answer is going to be in 3 sig figs. That's 1, 2, and 3. Don't forget to round up. That's going to give us $4.54 per gallon.